Good evening, dear students. Yesterday we have seen the problem number 2. So today we will start problem number 3. In this problem, what is the given set? Set A equal to 1, 2, 3, 4, 5 and 6. The relation given here, what is the relation means? Relation A comma B such that B equal to A plus 1 is the relation given here. So the number of elements in the set A equal to, just to say it is finite number of elements, and the number of elements also very small. The number is 6, very small numbers. So we can easily construct the roster form of the relation. So how to construct the roster form? So we will take that given relation B equal to A plus 1. So if I am taking A equal to 1, my B value will be 2. If I am taking A equal to 2, my B value will be 3. If I am taking A equal to 3, B will be 4. Similarly, A equal to 5, B will be, A equal to 4, B will be 5. A equal to 5, B will be 6. These are the elements in the relation. Now we will check the relation is a symmetric, reflexive and transitive or not. So first to check the reflexivity. How to check the reflexivity? Reflexivity definition is A comma A belongs to R for all A in the set. So check whether 1 comma 1 is available or not. No, clearly we can say that 1 comma 1 does not belongs to R. So I can write R is not reflexive. Clear? So next check the symmetry. What about symmetry here? So symmetry means what? 1 comma 2 belongs to R means 2 comma 1 should be in the set. Similarly, A comma B belongs to R means B comma A should be in the set. Check whether 1 comma 2 and 2 comma 1 is available in the set. For example, if I am taking 1 comma 2 belongs to R here, 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R. See that 1 comma 2 is available, 2 comma 1 is not available in the set. We no need to give only one example. We can give any number of example. For example, I am taking 2 comma 3 belongs to R means I can say that 3 comma 2 does not belongs to R. Like that I can give many examples, but only one example is enough to prove. So what we can decide? So R is not symmetric. R is not symmetric. Clear? Next we are going to check the reflexive over symmetry over. Next we will need to check the transitivity. We need to check the transitivity. So what is the transitivity here? So how to check the transitivity? See that transitivity means we need to show that A comma B belongs to R, B comma C belongs to R. This implies A comma C also belongs to R. Clear? So for example, we can say that 1 comma 2 belongs to R. Here 1 comma 2 belongs to R and 2 comma 3 also belongs to R, but 1 comma 3 does not belongs to R. So easily I can say R is not transitive. Clear? So this relation is not reflexive, not symmetric and not transitive. Clear? Question number 4. So what is given that set A equal to set of all real numbers. Set A equal to set of all real numbers. And what is the relation given here? Relation A comma B, relation A comma B such that A is less than or equal to B given. This is the relation given here. Clear? So there is relation we have to prove here. The set is not finite set. It's a relation, a real number set is given. So if you are trying to write the roster form of the relation, we have to write many elements, infinite number of elements in the relation. It is not possible. So we are going to prove generally. So what is that? First we have to check the reflexive property. So what is reflexive? A comma A belongs to R or not. Check whether here we know that A is less than or equal to A always true, because A is equal to A. Here it is given less than or equal to, so we can clearly say this is true. Clear? So next we have to it is true. So what we can write, A comma A belongs to the relation. So I can say that R is reflexive. I can say that R is reflexive. Next I need to check the symmetry. Clear? So check the symmetry. What is symmetry? What is symmetry? A comma B belongs to R means B comma A also belongs to R. For example, I can take here, I can give one example. For here 2 comma 3 belongs to R. That is 2 less than or equal to 3 is 2. But reversing that, 3 is not less than or equal to 2. Clear? But 3 not less than or equal to 2. So 3 comma 2 does not belongs to the relation. So 3 comma 2 does not belongs to the relation. Therefore R is not symmetric. R is not symmetric. So symmetry over. Next, what is that? Next, transitive. Clear? So transitive we will prove. Next, transitivity. So transitivity is what? A comma B belongs to R, B comma C belongs to R. We have to prove that A comma C also belongs to R. Here also we will prove generally. How means? Here A comma B belongs to R and B comma C also belongs to R. So A comma B belongs to R means, what is the meaning? A is less than or equal to B, and B comma C belongs to R. What is the meaning? B is less than or equal to C. See that comparing these two, B is greater. Comparing these two, C is greater. So we can say that obviously A is clearly less than or equal to C. So which implies A comma C belongs to R. So I can say that R is transitive. R is transitive. So what I can say? R is reflexive and R is transitive but not symmetric. Clear? Next question, question number 5. So what is the question given for us? R is a relation defined in the, so R is a relation defined here, A comma B, such that A less than or equal to B cube. Okay, well, this we have to prove that is reflexive, symmetric or transitive. We have to check. Clear? So what is the set given means? Set A equal to set of all real numbers given. So first we will prove the reflexivity. First we will prove the reflexivity. So what is reflexivity? A comma A belongs to R. We can say that it is reflexive. Check whether clearly we can say that 1 by 2 is not less than or equal to 1 by 2 whole cube, because 1 by 2 is greater than 1 by 8. So clearly we can say 1 by 2 comma 1 by 2 does not belongs to the relation. So R is not reflexive. Clear? Next we have to prove the symmetry. So what is symmetry? If A comma B belongs to R, then B comma A also belongs to R. I need to prove. For example, I am taking 1 comma 2. Clear? Here 1 comma 2 belongs to R. That is 1 less than or equal to 2 cube. That is 1 less than or equal to 8, which is true. But what about inversely? 8 not less than or equal to 1, because 8 is greater than 1. So clearly we can say 8 comma 1 does not belongs to R. So 8 comma 1 does not belongs to R means we can say that therefore R is not symmetric. R is not symmetric. Next we have to check the transitivity. Next we have to check the transitivity. So what is transitivity? A comma B belongs to R, B comma C belongs to R, which implies A comma C belongs to R. Clear? So I am taking two ordered pairs. There They are 3 comma 3 by 2 belongs to R, and 3 by 2 comma 6 by 5 also belongs to R. That is, what is that? 3 less than or equal to 3 by 2 cube, and 3 by 2 less than or equal to 6 by 5 cube. So what is the meaning? 3 less than or equal to 3 cube means 27, 2 cube means 8. It is true. Clear? Because we are cancelling mean 3 point something will come, clearly it is greater than. And 3 by 2 less than or equal to 216 divided by 125. Here also if it is true. But what about the third case, that is what about the A comma C case? Here clearly 3 does not less than or equal to 216 divided by 125, which means 3 is greater than that 216 divided by 125. So clearly we can say 3 comma 6 by 5 does not belongs to R. So what I can decide? If 3 comma 6 comma 3 comma 3 by 2 belongs to R, 3 by 2 comma 6 by 5 belongs to R, but 3 comma 6 by 5 not belongs to R, means R is not transitive. R is not transitive. So R is not reflexive, R is not symmetric, and R is not transitive. Clear? Okay students, remaining questions we will see in next video. Thank you all. Subscribe and share. Thank you.